Okay, after completing the installation process, the solar PV installer needs to check for the functioning of the modules. Means the system and the different components which are connected, they are properly functioning. This the installer has to ensure. So the installer needs to visually check the system after installation is complete. They should check that all modules and the system components are secured by bolts. Means proper fixing, proper installation is there. Then after that, he should check all wiring connections are properly made as per the diagrams and instructions. So there should not be any type of mistake or error in the wiring. He should ensure that. So yeah, next he should ensure all essential parts are grounded properly. Okay, so now including the disconnected and circuit breakers. So all type of the connecting or disconnecting devices, circuit breakers, they are turned off. All fuses have been removed out of their holders. But this is for the safety reasons. Proper grounding should be there, because if the grounding is not there, charge leakage and electric shock risk that is more. Okay, after that, he should check the polarity of all PV strings and PV arrays at both the combiner box and at the inverter. Means the polarity. Maybe it should not be like that positive terminal is connected with the negative terminal of the next component. Okay, next he should check open circuit voltage of all PV string and PV array, because they should be within the tolerance limit, the specified voltage that should be followed. Whatever is our as per our the system normal voltage. So next, the installer needs to ration the voltage through the circuit where shorting link is to be installed. So only if this voltage is 0, then install the shorting link across the PV output load side. Okay, while the side circuit that is open, means it is on no load, open circuit mode. So next, we do not insert a fuse or disconnect breaker towards the battery inverter during this step. Means maintain isolation. Then attach a PV string fuse in the first string fuse holder. In the sequence we have to move. The next, shut associated disconnect. Then measure the short circuit current. Okay, now we have connected. Shut the associated disconnect. So the short circuit current that is being flowing. Now just measure it. ISC value that is being flowing, we have to measure it. Then open the disconnect. Again, break the connection. Then move the fuse to each circuit string and redo the procedure. Means every uh, circuit string we have to check. So every time measure the current. The string short circuit current should be as per the specified tolerance. It means voltage and the current, open circuit voltage, then short circuit current, they should be within the specified range. They should not be more or below the specified level. They should be up to a required level or the standard. Next, remove the shorting link and open the disconnect on PV output circuit. After that, check that all the source string fuses are installed. Okay, fuses in the string, the source string. So estimate the PV array's open circuit voltage. Ensure that the open circuit voltage is close to the lowest individual string open circuit voltage, because here the voltage level that should be the same. Then only we are able to connect them. If the voltage in one individual string that is different from the another one, then our system won't work. A different voltage level. The net output we are obtaining, that will be at some other value, not as what we are requiring. The measured are within the specified tolerance. Okay, our value should be within the specified tolerance limit. So next, if ground fault protection device trips in any of the above test, Okay, means the ground fault protection device is there, and if it trips in any of the steps which we have done for measuring the voltage, for measuring the current, that is open circuit voltage and short circuit current, but ensure there is only one grounding point and follow troubleshooting procedure to find ground fault. Okay, after that we have to find the ensure whether there is any ground fault or not. So next we have to connect the inverter, PV array and the utility source by closing output disconnect or the circuit breaker. Whatever equipment we are using for connection and disconnection, we have to close it. Okay, and yeah, so output disconnect circuit breaker that should be closed prior to the input disconnect or circuit breaker. The inverter will remain off for some time with its input voltage close to a PV array open circuit voltage. For some time the inverter that is off with the applied voltage of the output from the PV array. We have applied it from the inverter and still it is, we have not switched it on instantly. So when the inverter begins delivering the power to the load or the grid, means you have switched it on. After that connected, then you switch it on. The inverter AC current output, that is the output current, that is AC. That is the function of the inverter from DC to AC conversion. Okay, as well as the DC input voltage. Okay, so the input is DC, output is AC. So input DC voltage and current will reach maximum power values. Okay, so when we have started the inverter, and correspondingly the voltage at input, current at input, current at output, they will reach the maximum value. So we have to monitor inverter output current using clamp on current probe that we've seen in the tools which we require for this installation process. So record inverter output AC current, voltage and frequency. We should make it sure that they are within the specified limit. The next, monitor inverter DC input voltage and current. So the input DC voltage and the current, we have to monitor how much voltage and current is entering the inverter, and they should also be within the specified limit. They should not cross their maximum allowed value. Okay, now next we come to the next topic, that is earthing of the PV system. So the panel installer must ensure the proper earthing of the PV system to protect the system from lightning. Because there is a risk, it is always on the rooftop, the risk of lightning that is associated with the PV system. So we have to provide proper earthing. So the reasons for earthing, for grounding, so equipment. First reason, equipment and system grounding is required to provide earth as a common reference point for various voltages to restrict voltage because of lightning, accidental contact line surges with lines having high voltage, and to provide current path for operation of overcurrent protection devices. So why do we need earthing, proper earthing? Because the over voltage, the over current which is induced in our system, that should be diverted towards the ground, towards the earth. So this is the first reason of providing earthing. So how that could be, the over voltage, that kind of situation can occur. In which cases, how it could occur? In case of lightning, it could induce extra voltage, over voltage. Then in contact with other live line, some surges, that may induce a high voltage in our system, PV system. Okay, some type of overcurrent. These things can occur. So we have to provide a alternative path towards the ground so that this over voltage that should not harm our system, any component in our system, in our load as well. So next, reason is that equipment grounding maintains protection from shock, which are as a result of ground fault. So it's also the protection from electric shock. The grounding consists of grounding electrode, grounded conductor, and the grounding conductor. So rules for grounding of PV system. First rule, the grounded conductor is grounded at one point via the grounding electrode, and the grounding conductors connect all equipment enclosures to the grounding electrode via grounded conductor. Okay, means all of the components, they should be properly grounded. Okay, by grounding electrode and the grounding conductors. So all of the equipments in our system, they should be connected to the grounding conductors. These conductors should be connected to the grounding electrode. So next rule is the equipment chassis is connected to grounding electrode via grounding conductor. Along with equipment, the chassis, that is also to be connected with the grounding conductor. Next rule, the PV array, combiner box, inverter, DC and AC distribution boxes, all of these equipments, they should be grounded. Next rule, the grounding conductor must not be fused or switched. We have to ensure that. The next array support structure should have equipotential bonding and grounding arrangement to the supporting structure. That also should be there, connected, properly connected with the grounding structure. Okay, so the discharge, the capacitive discharge, okay, or we can say that the voltage or the over voltage induced, okay, that should also be diverted to the ground in the array support structure as well. So component, main component, then the supporting structure, all of them, they have to be properly grounded. Okay, next. All grid connected PV systems have DC voltage well over 50 volt and require system ground. So DC system grounding is done by connection of a negative conductor on ground at a single point. So the DC system, so voltage, that is 50 volt. Okay, so basically the PV system that is generating the voltage, and the voltage level that is taken 50 volt. So they require proper grounding. Okay, next, the single point ground is located near the PV array for battery system protection from voltage surges. Surges, that is a hike, sudden hike in the voltage. Okay, so this system, this high voltage should not reach the battery. So protect battery from this surge of voltage surge. So there should be a grounding provided there to protect the battery system. AC system can use the same grounding electrode. If two separate electrodes are used, one for the DC, one for the AC, so they need to be bound together. Next rule, jumpers. Okay, jumpers can be installed for system and equipment grounding conductors to maintain ground continuity if one of the equipment is removed from the system. Like, means it should not be like that we have removed one of system and the whole circuit, grounding circuit, that is broken. There should be jumpers who can make the connectivity if any component is removed. Still the circuit is complete. The grounding circuit, that is completed. The next rule is that the ground fault detector and interrupter, so GFDI in the short we can call it as. So ground fault detector and interrupter is used to isolate grounded negative conductor from ground under ground fault condition. because the ground fault condition could also be there. The grounding is not a proper like that. Also ground fault, okay, that occurs. For that we need a detector and interrupter. The GFDI also isolates undergrounded positive conductor. So most grid tie inverters provide inbuilt fault protection for ground. Okay, so that is we can say the property or the advantage of grid tied inverters. If not, an external fault protection for ground is required. If the inverter is not providing us this facility, then we need an external fault protection for the grounding. Okay, so here we shall stop now.